Welcome to your Unit 1 Lesson 2 Marketing Analytics class. In continuation to Lesson 1, today we'll talk about Lesson 2. In Lesson 2, we are going to study basics of statistics. As you know, in Lesson 1, we discussed in detail about data, which we called big data, and we tried to understand a lot of details about data. In this particular lesson, we'll talk about stats, but since you have already studied stats in detail, we'll be covering some of the things which are required for your analytics. In fact, all of stats is required, but here it is an introduction wherein the learning outcomes would be the sources of data, big data, descriptive analytics, visuals, and quantitative measures, how the measures in quant like average and spread is used in descriptive analytics, and last we'll take a small case study uh, to showcase the usage of stats. So let us start. When we talk about sources of data, as you already know, you can have primary and secondary data, social media data, Internet of Things, industrial Internet data, or the business data, or maybe all the four sources. So when we talk about primary and secondary data, so primary data is that which you collect yourself. So you trust that data because you have collected it. Secondary data is which is from someone else. There are three things which you need to keep in mind in case of primary and secondary data. Number one is the data reliable? Is it representative? Is it truly representing the random sample, the randomness? When you collect data from social media, because this data can exist in any form, it can be text, it can be audio, it can be video, it can be a multimedia. The thing about social media, maybe from Twitter, maybe from Facebook, or any other social media platform, is very badly structured, and the structure is not very uniform, and there is a lot of variability in this data. When we talk about Internet of Things or industrial Internet, so you use different devices. For example, your mobile phone, what is the screen time? You are wearing a Fitbit, so which gives you the number of steps, your BP, and other health parameters. So there are a lot of instruments. There are like your electricity meter for power consumption at your home, your water meter. These are all smart meters which are continuously without any break recording the data, and it is all quantitative, and it can be very voluminous. That means huge chunk of data if you have to handle as one of the sources of data, which is Internet of Things or industrial Internet. Then comes your business data. Business data is your business details. For example, you're working for a company, and there you are exchanging some chats, some emails, which are business emails. So that is also business data. So any credit card transactions that you're doing, maybe if I talk of Sensex, so the indices that you are monitoring, so that is also the data which is the business data. So the business data is highly variable in structure, and you need to look at the value of that data before putting that data for your analytics. When we talk about big data, so we talked about, I'm just talking of big data here. So sources of data, as we have seen, there can be many sources of data, and the data, big data, will exist in many forms, and the reliability level of the data collected from different sources in different forms will be very different. So what is the first thing we do before we use it for analytics? We first acquire the data, we create the data, That means we remove the duplication and we try to take all the things which are not relevant and we cure the data. That is what we say. And then we manage the data carefully. And the model that we use for that is ETL model, that is extraction, transform, and load. So big data has 6 V's to it: the volume, the velocity, the variety, the veracity. The veracity is the truthfulness of data, and then the variability and the value, because value drives the big data to be used for analytics. As we discussed in the last lesson, I'll take it further here as the value chain of analytics, which we call as analytics value escalator. So the more value you want, the analytics level will go up one step. So as I talked in Hindi, the 4 things, if you go to a doctor or in this COVID-19 situation, so the first thing we do is क्या हुआ, then क्यों हुआ, then आगे क्या होगा, and last जो आगे होगा उसको अच्छा कैसे करें. So when we say that, so the first is क्या हुआ, that is descriptive analytics, what happened. क्यों हुआ is diagnostic analytics, which is why did it happen. आगे क्या होगा is predictive analytics, which is what will happen next. And last is आगे जो होगा उसको अच्छा कैसे करें is prescriptive analytics. How do we make good things happen? You go to a doctor, the doctor tries to see what has actually happened with you. Second thing, he looks and tries to understand why it has happened. Third, he is trying to tell you what is going to happen tomorrow, day after tomorrow. And then he'll prescribe a medicine to you so that nothing bad happens tomorrow and day after. So that is what we say is the analytics value escalator. So let us start with descriptive analytics. And I'll try to group in the stats into descriptive analytics, because without stats, analytics cannot work. Now, in descriptive analytics, we try to examine the past data very carefully so that we have a good understanding about the past. Based on that understanding, we try to gain insight about future, what is going to happen. For example, for descriptive analytics, there is a certain rise in crimes in a particular city. So first thing we do is we do the data acquisition of the past. Then we try to have the historical patterns coming out of that data. And then we try to correlate the things and we try to understand the rate of crime in the past from that historical projection. We also try to correlate the crime with so many factors, for example, unemployment, migration, price rise, scarcity of common commodities. So we try to have that correlation. So this whole process is what we say is descriptive analytics. Now, how we use stats in descriptive analytics is what we are going to see now. So you already know the basic tools of stats. You have studied that well, right? So let us look at the measures and visuals, that is quant and visuals, and try to use them in our studies. So we'll talk about 2 things. One is the quantitative measure, which we call as quant, and second will be the visuals. Now, for any business, generally you might have seen there are data reports based on key performance indicators, which we call as KPIs. So there could be standard reports, there could be some special case reports pertaining to any scenario, like we were talking about spike in crimes in a particular city. Then we try to drill down to particular uh, area, and we try to get all the details in that specific area, and we try to present that through a dashboard which contains everything. So let me talk about quant and visuals first. So either I work on one quantity or I work on two quantities. So the scope of this lesson, for the scope of this lesson, I'll not go for multiple quantities, but it will be the same as two quantities. So when I talk about one quantity, what is the quant measure that we look at? So we will be looking at two measures, two quant measures. One will be the mean and the other would be the standard deviation, which gives you the spread. And for the visuals, we'll be talking about histogram, that will be the visual. In case of two quantities, the quant would be correlation and the visual would be scatter plot, a scatter diagram. Now, this is how the dashboard looks like when any business is presenting any report. For example, this particular report is on for Vision Corporation, where they are talking about their expense summary with the budget and then how much each department is having the expense of the budget, and then we have a drill down, a detailed report on a particular area. So that we call as a dashboard. This whole is the dashboard for that. Now, when we talk about the quant measures, so firstly, let's talk about how to measure the average, the mean, and I'll take one example how we use that in our descriptive analytics. So I encourage you to go to this URL. Now, this is for the World Trade Organization. So World Trade Organization, they present a World Trade report every year. Now and it's very interesting because it is all about figures, the quant measures, and the visuals, the diagrams, the histograms, and the scatter diagrams, and whatnot. So it's very interesting to go through that. It's around 200 to 300 pages report. I encourage you to go and just go through. Don't be very serious whether you understand or not, just how this representation is made. And mind you, this is just basic few measures, and these are quant measures, and we are talking about average and standard deviation. So let me emphasize that through this world report. So when we talk about the average, let us summarize the things through this report and try to understand, and then we'll take up the standard deviation. If you look at this diagram over here, now this talks about the world trade volume for the last 22 years, not the last 22 years, last 20 years, and 2 years you will see the projections, 2021 and 2022 will be the projection. So this is the trade volume as per your latest 2020 World Trade Organization report. So over here, if you look at this, the blue line indicates your trade. This is the world trade. Now what they have done is they have taken the average trade of each country and for all the countries, and then they have calculated the world average, that is for the world trade, and this is one single quant measure, which is a summary quant measure, and then they plotted this graph. So the blue line gives you the trade, right? The world trade volume starting from 2000. So if you take this dotted gray line, so that is a trend of 1990 to 2008. So if you follow this gray dotted line, you will see in 2008 there was a big recession. So if we just follow the trend based on the historical pattern from 1990 to 2008, this gray dotted line would have gone. So that is the trend which should have happened. But because of the recession in 2008, there was a dip which you see here uh, on the blue line. So we are not following that trend. And you see the blue line which goes below the dotted line. And that is how we look at this. But if I look at the trend from 2011 to 2018, right, that is the yellow dotted line. So that is the trend. But what happened? We were following that trend, and that is what we were doing. But what has happened in 2019, late in December, we had this COVID 19, this pandemic. So that is going to affect us hugely. So this is where we stand today. So you see the red dip there and the green one. So if we are optimistic, uh, then we will follow the green projection which has been shown here. But if we are pessimistic, then it will be the red one. Here the base is 2015, which is 100. So in both the scenarios, it will be negative. So the world trade volume will go down from 2015. So if we take that as the base here, so it is going to be below 80 if it is pessimistic, the red one, and it will be between 90 and 100 if we are optimistic, that is the green dip that you are seeing here. Now this is a measure of the average from the World Trade Report that I am showing you from 2020. Let me talk about the standard deviation. So this is another report which has been taken from 2014 World Trade Organization. This is on page 134, where on the x-axis it is the energy standard deviation in the dark blue line, and the green one is for other metals. So let me just look at energy, that is the dark blue line, standard deviation. So this is the measure of spread. So if you look at the initial year 1998 and initial 4 or 5 years, the prices were fixed if I talk of oil, right? So there is no standard deviation, there is no spread. So that is why the curve is very flat. So if today we talk about COVID, so we talk about flattening the curve. That means there should not be any variation, right? So the average so should stay there, and there should not be any spread. So that is what we try to measure. So then later on you see there is lot of volatility, and that is where the oil prices were changing. And if we come towards 2012, 2013, so there is a lot of volatility over there. So this is how you summarize using the quants and using the visuals by using the quantities. So that was a single quantity. So that was one was the average world trade, and second was the standard deviation for the energy. So when we talk about two quantities, so let us take another example again from the World Trade Organization report. Now this particular graph that you are seeing is a scatter diagram. So on the x-axis you are seeing the natural resource income, which is the percentage of GDP. That means the natural resources of the country, how much of those resources are contributing towards your GDP. And on the y-axis is the Human Development Index. So one thing to ponder, one thing which you should think of is why the GDP, if you see on the x-axis, is negative, -6, -4, -2, and many countries fall into that. So can you guess why it is so? Maybe you have guessed it right. That means there are many countries who don't have natural resources, and so there is no natural resources income which is contributing towards the GDP. Japan is one such country, whereas India doesn't fall in that. So, what is the correlation between these two parameters, so which we are talking as natural resources percentage of GDP versus the Human Development Index? So, there is a negative relation between the two, as you can see the green line, and that is what the scatter diagram gives us the correlation. And it is very surprising to know that the countries who are having lot of natural resources which are contributing towards their GDP, there the Human Development Index is less. So very strange, but that is what we come to know from these analytics and from using stats in analytics. Now, what I'll do is we'll talk about visual and summary quant measures to understand the concept for descriptive analytics in detail. What I'll do is I'll take a simple example, a small case study, you can say, wherein what we do is we run a business who have come up with a fancy pair of sunglasses, and I would like to run a market survey where I would like to know from people how much they are willing to pay for this fancy pair of sunglasses. So that is the market survey. So once I have done the market survey, what I do is I'll draw the histogram. As you can see in the histogram, on the x-axis it is the willingness to pay, on the y-axis it is the frequency. What that means is, for example, there are around two people who are ready to pay 50 rupees for these glasses, and the maximum is 150 as the price. That means around 80 people, right, are willing to pay 150. So this is the histogram which is showing us the willingness to pay for the sunglasses. Now, let me introduce another product. So the company, apart from the sunglasses, would also like to sell headphones. And we did the market survey for the headphones also. And for the sunglasses, you have seen the histogram. For the headphones, this is the histogram which has come. So when I compare these two histograms, so I'll immediately come to know that I can fix one, maybe the mean, like we were seeing 150 as the price which we can fix because it is a bell shape and this is the normal distribution, and one price will suffice for all the market segments. Whereas for my headphones, because of the histogram, I can see I cannot charge the average for all the people because the willingness to pay is distributed in a bimodal form of histogram. So that means I have to keep two prices. One, a lower price for the people, for the market segment, which is asking for that price, and then another bell-shaped curve, the second one, which is the higher one in this bimodal histogram, where I give them a sophisticated smart headphone and charging a higher price. Now, when we look at the quant measures, we talked about mean and standard deviation. Let us understand mean and standard deviation in detail. So for mean, when we look at, so mean is sum of all the values divided by the sample size. So in the case of sunglasses, the mean comes out to be 150 as we discussed. And the standard deviation is abbreviated as sigma. It is the root mean squared deviation from the mean. It gives us the spread of the data. And in this case of sunglasses, the standard deviation comes out to be 40. Now let me introduce a third product to make you understand the stats in more detail. The third product, for that what we have done is we did the market survey. So we have the mean and we have the standard deviation. And then we have the visual, which is the histogram. But firstly, we are looking just at mean and standard deviation. So uh, my question would be, so here it comes. So the mean comes out to be 106 and the standard deviation is 104. So uh, can I say that 50% of the people are willing to pay less than 106 and 50% of the people are willing to pay more than 106 as we have seen in the past? And my simple question is, how many are willing to pay more than 106? Is it 50% of the people who are willing to pay more than 106? So if I look at this, I'll say yes, but unfortunately the answer is no. Why? Because when we have drawn the histogram, what you look at this is that it is not, if you look at 106, right? If you look at 106, which is the mean, so no, it is not 50% who are willing to pay more than 106 because it is not evenly distributed. It is not, the spread is not even across the mean. So then there comes a median. So median is 75. So that means 50% of the people are willing to pay, right, less than 75, and 55% of the people are willing to pay more than 75. So 75 is not the is the price if I want to keep, but it is not the mean, which is 106. So here the mean and median is not the same, is not equal. So this is very important to understand. So what we derive from this slide is that we have to look at the visual and the quant together. We cannot infer anything from quant itself, from mean and standard deviation. So when we talk about normal distribution, let us understand normal distribution in detail. So in case of normal distribution for the sunglasses, as I said earlier, the mean is 150, standard deviation is 40. So most of the values have a central tendency towards the mean, towards the average, and it is the symmetrical distribution. That means the mean is equal to median. That is very important to understand. The example, most of the things, remember, most of the things in this world, they follow normal distribution. I said most of the things, but not all. So when they follow this, example could be weight of males with same height and age will follow a bell curve. Another thing to remember in this is that 68% of the data will fall within one standard deviation of mean. For example, it is standard deviation is 40 and mean is 150. So 150 plus minus 40, 68% of the data will fall within this. If I take two standard deviation of mean, so 95% of the data will fall in that, as you can see in the figure. Now, not all the things in this world follow bell curve. Remember this. So as we have seen in case of sunglasses, which follows a bell curve, willingness to pay, that survey we are talking, the data that we collected, the headphones, it was bimodal, and for the third product that we talked about is asymmetric. So with that, I end this session, lesson 2. So let me summarize the things for you. So we talked about there could be many sources of data, and we talked about 4 different sources, and we tried to look at what all things to see when you pick data from different sources, and we use the ETA model for that. Then we talked about before we apply that data, use that data for analytics, we have to cure that data. And then we also discussed the stats, how to use stats in descriptive analytics. We talked about quant, that is the quantitative measures, that is the summary measures, and we talked in detail about two parameters, average and spread. And then we discussed through the example, through the case study of selling three different products and looking at their quant measures and the visual measures. And we came to the conclusion that the quant and visual measures have to be seen together in order to use that in descriptive analytics. So that was this lesson. Here is your quiz for this lesson. So please take out your notebook and pen and please write your answers so that you can check the answers later on. Your first question is, which source of data is most reliable? Your second question is, what are the two major quant summary measures? And your third question is, what percentage of values fall within two standard deviation of mean in bell curve? I give you some time to write your answers while I wait. And I hope you have written your answers, and I pray that all the answers are correct. So the first answer is primary, the second is average and standard deviation, and third is 95%. If you have any questions, you can ask me or write to me on gsinghjmt@gmail.com. I'll try to answer that within 48 hours. I encourage you to go for some further reading on basic stats where you can enhance your learning. Based on this lesson, you will be able to understand this particular presentation. So thank you very much for today's lesson and being such patient audience. And I'll see you in the next lesson soon. Goodbye.